Okay, hello everybody. So I'm Dimitri. This is some additional information on my main talk regarding the volumetric video and its cloud rendering process. And in this short presentation here, I would like to go much more into the detail on how to measure the motion to photon latency and investigate further components of the latency chain. For that, let's quickly remind you on the setup, how the system looks like. So we're gonna use 2D client running in the browser for the measurements. We're gonna run on the server side the console application using the same cloud rendering library. And this render texture we're gonna generate ourselves. So we will not use volumetric player anymore. We will just generate simple bars like this in our console application. So the web client will establish the connection. After this, it will create a point-to-point connection and create a WebRTC stream. And after the stream is established, we're gonna start our measurement process in terms of which runs like this. So we're gonna send some information to the server to request the texture color to change, start the counter. As soon as the texture is changing and send back and we detect this color changed, we basically stop our measurement and we did one measurement. And then in the next step we request the color to change again and do the same. And so we do this 50 times. After this, I'm gonna write some values here, so we're gonna see what kind of overall motion to photon latency we measured on average. And then we're gonna take a look into how much of this is actually coming from the media pipeline. And then we're just gonna measure round trip time using ping also as well to basically roughly approximate the network latency. And then together, having those three values, basically we know how much of latency coming from other components, which we cannot easily measure. And let's get into it quickly, so I don't wanna waste too much of time. So for that, we need to connect to our Amazon instance first. SSH blah blah, so we're gonna connect. So there's a screen, and then we're gonna use GStreamer latency tracing capabilities to store some log files. And for that, we need to start our console application setting certain values. And this you can find in this repository if you would like to do something similar. So, but basically you need to set this string before, right? So, but actually I have a comment already here. So it's then basically gonna write our traces log file. Let's run it. Now we can go to https hi-demo.de, go to the latency measurement page, go to HI-demo, port 8080, connect, and do 50 measurements. Okay, so we did 50 measurements. On average, let's say we are at 60 milliseconds. I stopped the server. So we have a traces file here. So I'm gonna copy this file. I'm gonna copy this traces file to my MacBook. So it's here. And then I'm gonna go to this GitHub repository, which I just showed to you, and run node on this log file. And for some reason plotting isn't working. And I have no idea why. Let's restart Chrome. Okay, I don't know what it was, but things like that happen, I guess, when you present some stuff. Okay, but this is basically our latency of the media pipeline over time, which you see here. So this is this media pipeline, WebRTC, encoder, video, convert, app store. So you can see like all of these individual components. I mean, you can see much more components since our pipeline is much more complex than we show here. But in general, you see the most important part, contributors to the latency, are visible in this table as well. So we have video encoder, obviously, 12.69, so it's about 80 FPS, and this is important here. So we have 16.38 milliseconds of total latency coming from the GStreamer pipeline. Now I did a mistake. I don't remember. No, it was 60 milliseconds, right? I closed the Chrome browser. I lost, but I remember it was 60 milliseconds we measured. So we have basically 60 milliseconds measured motion to photon latency, and from that we have, let's say, 16.4 milliseconds coming from the media pipeline. And then let's also ping our server, so we kind of have some average approximation of round trip time, which you can see here. It's on average 15.9. Okay, so then we have 60 minus 15.9 minus 16.4, 27.7, 27.7 coming from all other components. And this is also interesting data, I believe. And obviously inside here we have some processing time we spent in our server to receive the data, to process it and so on, so that the render texture creation and so on. So this is obviously inside there, and then as also inside there is a decoding time on the client side, and also displaying time. And for displaying time, maybe it's kind of interesting, I use request animation frame on a JavaScript, and if you read the documentation here, for example, you see that the number of callbacks is usually 60 times per second, but it will generally match the display refresh rate of the most web browsers as per W3C recommendation. And by the way, there's actually some nice project online you can use to basically figure out how much latency, what kind of display refresh rate you have from your browser. So request animation frame in Hertz. And you can see here that it's something about 60 FPS as stated in the documentation, and it will result in worst case latency in 16.67 milliseconds, but we can say on average it will be something in between, so this value divided by 2, so the half of it gonna be basically coming from display. And yeah, so you can actually say 27.7 minus 16, what would we measure here? 16.67, 67 divided by 2, so we have 19.3 milliseconds coming from video decoding and some processing, which might be also interesting. Okay, I hope that it provided some insights on this. I believe it's kind of interesting to see media pipeline latency over time, which is quite interesting to see. And maybe one last thing, that you can actually see here a lot of different components in the pipeline, but as I already mentioned, the latency of the video encoder is the most dominant one, and we also here we see that some conversion of the texture. So we need to convert the texture from YUV to RGB, or from RGB to YUV, I'm sorry, different way around. And this also takes some time. So as you can see somewhere here, here, video convert. So this takes on average something around 1.1 millisecond, as you can see here as well. So, but this is the main contributors to the latency inside the GStreamer pipeline. Okay, thank you, and have a